Scenario: two baseball players on an ice rink are connected by a cable and are initially at rest with respect to a nearby tree. Baseball player A, which is in red, throws a baseball to player B, which is in green. Figure 1 shows the player A holding the baseball and getting ready to throw it. Figure 2 shows the player immediately after the ball is thrown by player A. The ball's in the air. Figure 3 shows the player immediately after the ball is caught by player B. The question: you're going to describe the motion of player A in all of the figures. At the start, it says initially at rest, so figure 1, player A is not moving. Then player A throws the ball. There is a force that the player is exerting as he throws it to the right, and as a result, due to Newton's third law, there's an equal and in the opposite direction force. So in figure 2, the player A is now moving to the left. Once the ball is caught by player B in figure 3, they stop moving because it now goes back into equilibrium. The second question, you're going to describe the motion of player B in all of the figures. In figure 1, player B does not move because it is still in equilibrium. Then when the ball is thrown, figure 2, it shows that the baseball player green, player B, has to move to the left because they're connected by the cable. Once the ball is caught in figure 3, the player then stops because it now goes back into equilibrium. This should be a 3. Okay? Notice that in figure 2, that's where the motion occurs. Okay? They all move towards the left because the red baseball player A, is the one throwing the ball. This question would be completely different if originally it's the green baseball player B, that's throwing it. If it was player B throwing it, the thing that would change would be figure 2. It would be moving to the right. Okay? There you go.